Welcome to SAP 2000, a comprehensive, yet easy to use, state-of-the-art finite element analysis and design package. In this tutorial, we will create a simple 5-panel truss bridge constructed of steel 4x4 double angles with a concrete deck. Before we get started with modeling, let's take a quick look at the SAP 2000 interface. All the options are available through the top menu bar. Toolbars offer buttons that provide access to commonly used commands, including snaps, zooms, and views. An icon next to a menu command indicates that this item is also available as a one-click button. Typically, one defines materials and section properties, draws the physical objects, selects these objects, and then assigns properties and loads to the objects. We start the modeling process by clicking on the File New Model command. SAP 2000 offers a wide range of parametric-based templates to help create your models, including a slope truss template that is similar to our model. However, we will start by using only a grid definition. A thoughtfully planned grid system can result in enormous time savings, so spend some time at the start to make sure your grid captures the main geometrical features of your structure. Note that we will use the units of kip inches as our default, but that the units may be changed at any time. Click on the Grid button and input the number of grid lines, followed by the spacing values. Note that by explicitly specifying the units, we can enter these values in feet rather than inches, and the program automatically handles the conversion. Directly under the display title bars is an indicator showing the model status. This indicator will display either object model or analysis model. Objects represent physical members and are typically what the user draws in SAP 2000. To make viewing our model easier, we will reduce the size of the grid bubbles. This is done through the Coordinate Systems Grids command, and we will use a bubble size of 36. Next, we will define a material to be used for the double angle sections. Click the Define Materials, and then click the Add New Material Quick button. Select Steel from the Material Type drop-down list, and then ASTM 836 from the Specification list. This is all we need to do to define a material when selecting from the pre-defined standards. Next, define the truss objects by clicking on the Define Frame Sections command, and then click on the Import New Property button. Verify that steel is showing in the property type list, and then click on the Double Angle button. Select and open the section database, and select A36 from the material list. Clicking on the plus button allows editing of the material or additional materials to be added. Scroll down the double angle list until you locate the 4x4s. Select the entire group by holding down the Shift key and left mouse button simultaneously. Now that these sections are available to the program, we are going to assign them to an auto-select sections list. This list will tell the program to choose from these angles when analyzing and designing the model. Name the list Truss and select all the angles. The program will use the median section as the starting section in the initial analysis. We can now assign the truss list just like we would an individual section. Make sure that the left view or plan view is active and set to z equals 0. You can make a view active by clicking anywhere in the window, and you can verify that it is active if the display title bar is highlighted. Also note that the active view location is indicated in the other window. Next, make sure that the Snap to Points option is on, and click on the Draw Frame icon. We are going to draw the truss objects and want the program to assign members from the truss auto-select list we created. Start by drawing the bottom chords. Click at the beginning and ending points to draw a single object that represents the physical member. Also draw the first cross object. A right click will stop the drawing action, but leave you in the draw mode. Hit the Escape key or Select button to leave the draw mode. Select the first cross member by clicking on it, and go to the Edit Replicate command. Specify a dx of 144 inches and a number of 5 to replicate across the bottom plan. Select both of the chords, remembering that they were drawn as single physical objects. The next step will tell the program to internally mesh these members so that they will be connected to all of the elements that frame into them, although from a selection and design standpoint, they will remain single members. As a general note, when in the selection mode, if you window from left to right, only items completely within the window will be selected. However, if you window from right to left, everything touched by the window will be selected. Next, select the first 5 cross members and go to the Edit Replicate command. Set dx equal to 72 inches, dz equal to 144 inches, and number to 1. This will replicate these objects at the top level. Next, shift to the top plan using the toggle keys. And draw the top chords using the Draw Frame command in much the same manner as the bottom chords. Hit the Select Mode key to exit the draw mode, and select the 2 top chords. Once again, because they were drawn as single physical objects, we need to go to the Assign Frame Automatic Frame Mesh command to have the internal mesh created so that they will be connected to the other objects. Clear the window of the assigns, and then change the left window to an XZ elevation view at y equal to 0. Draw 1 bay's worth of diagonals using the Draw Frame command. When done, right-click and then hit the Select Mode button. Next, select the diagonals and go to the Edit Replicate command and set dx equal to 144, dy to 0 with 4 repetitions to generate the members needed to complete 1 truss. Select all the diagonals and click on the Assign Frame Releases and set the M33 moment releases at both ends to on. This will result in the diagonals acting as pinned members. Select all the diagonals once again and replicate on the other side. Change the left window back to an XY plan view at Z equal to 0. And define the concrete deck by going to the Define Area Sections command. We will call the area section deck and use the default 4000 psi concrete. The thicknesses will be set to 5 inches. Next, draw the deck by using the Draw Rectangular Area command. Make sure that the property is set to deck and click on two opposite corners to complete the object. Right-click anywhere on the deck to display the area information form. Object assignments and loads may be edited directly from this form. Select the Assignments tab and double-click in the Automatic Area Mesh Edit box. Select the mesh area based on points on area edges option and check the intersections of straight line objects. Since the deck was drawn as a single object, we are going to mesh the area object so that it will be connected to the intermediate points on the trusses. Next, select the two joints at the right end and go to the Assign Joint Restraints command and select the roller support. Follow the same procedure for the joints on the left, but assign a pin support. A check of the default load patterns indicates that we have one pattern. Dead load with self-weight included. We will now add a live load pattern. Now we will assign loads by selecting the deck object and going to the Assign Area Loads Uniform command. For the dead load pattern, we will apply a uniform load of 10 pounds per square foot in the gravity direction. Repeat the selection process and this time assign a uniform live load of 100 pounds per square foot in the gravity direction. Repeat the selection one more time, but this time we will be assigning a stiffness modifier to the deck. We are going to set the membrane modifiers equal to 0, which will prohibit the deck from carrying axial loads. We do this to keep the deck from acting as a flange for the bottom chord of the trusses. The model is now complete. To get a less cluttered view of our model, set the 3D window to active and go to the View menu and set the Show Grid option to off. We can also see the deck better if we use the Set Display Options command and fill the objects. We are now ready to analyze the model. Click on the Analyze, Run Analysis command and set the modal case to Do Not Run, as we wish to do a static analysis only. Click on the Run Now button. After the analysis is complete, the active window is updated with the deformed shape. Note that the analysis model is now shown. Information about the analysis process may be accessed by going to the File, Show Input/Output Text Files, and selecting the log file. Here, you can verify the size of your model and that the analysis was completed. Set the left window to active and click on the XZ View button to generate an elevation. Next, click on the Display Show Forces command and select Frames. Here you can choose the load case and type of force to be displayed. A right mouse click on an individual object will bring up detailed force diagrams for that particular object. Next, click on the Display Show Deformed Shape command. Similar to the forces, a right mouse click on a joint will display the displacements for that particular location. We are now ready to start the design phase. Design options may be accessed through the Design menu. For our case, we will be using the steel frame design, and if you go to the View Revise Preferences command, you can set the various design parameters, including the design code to be used. For our model, we will use AISC LRFD 99. Next, go to the Design, Steel Frame Design, and click on the Start Design of Structure command. After the design is complete, the design sections are displayed, and if we window in, we can see that the program designed the chords as single objects, even though for analysis they were meshed into smaller elements. A right mouse click on a design member will bring up stress check information, including the governing load combination. Note that the design section differs from the analysis section, so typically another analysis would be run, iterating until the two sections were the same. Clicking on the Details button brings up a calculation sheet with all the pertinent design values. As a last step, typically one would check that the design and analysis sections match by clicking on Design, Steel Frame Design, Verify Analysis versus Design Sections, as well as checking that all members pass the stress check. This concludes this tutorial.